In this video, we're going to learn how to model ionic bonding between a metal and a nonmetal using electron dot diagrams. So one thing to remember from our previous video is where our metals are and where nonmetals are. Ionic bonds only occur between a metal and a nonmetal. So let's review electron dot diagrams. We know electron dot diagrams show only the valence electrons for each element. So sodium has only one valence electron, so it's going to have one dot around its symbol. Chlorine, on the other hand, has 7 valence electrons, so it's going to have 7 dots around its element. So we know we can draw our electron configuration in order to model our ionic bonding. We don't always need to write out our full electron configuration to figure out how many valence electrons each element has. What we can do is we can remember this table on the periodic table. We can remember that each column or each group has a specific number of valence electrons. The first column has 1 valence electrons. The second column has 2 valence electrons. We're going to skip our transition metals for now. We're going to look at this column over here, our 3A. Every element in this column is going to have 3 valence electrons. 4A is going to have 4 valence electrons, and then it just goes 5, 6, 7 until we get to our noble gases, which has 8 valence electrons. So using this table, we can remember the valence electrons for each element. So what we want to do now is model ionic bonding. We know that our metals are going to transfer its valence electrons to a nonmetal. So sodium is going to transfer one of these valence electrons to chlorine. A result of that is now, because sodium lost 1 valence electron, it's going to have a positive 1 charge. And now because chlorine gained 1 electron, it's going to have 8 electrons around it now with a negative 1 charge. There are specific steps you can remember to model ionic bonding. The first thing you want to do is draw the electron dot diagram for each of the elements that are given. Then you want to draw arrows or an arrow to represent the transfer of the electrons. You're transferring your metal electrons to a nonmetal. Then you want to add atoms until all elements have a noble gas configuration. And that means that each element has 8 valence electrons around it. Then you want to draw all resulting ions using their charges. So let's create an ionic model showing the ionic bond formation between magnesium and chlorine. The first step is to draw the electron dot diagram for magnesium and the electron dot diagram for chlorine. So you can see magnesium has 2 valence electrons around it, and chlorine has 7. So chlorine only needs 1 more electron in order to have a noble gas configuration. So magnesium is going to transfer its electron to chlorine, causing it to have 8 electrons. We know that magnesium has 1 more electron left in order for it to give all its electrons away. So we need another chlorine atom in order for it to transfer its electrons. So one of the electrons are going to go to the 1 chlorine, and this one is going to go to the 2nd chlorine. The result is, because magnesium gave away 2 electrons, it's going to have a positive 2 charge. And we know each of these chlorines gained 1 electron. So each of these chlorines are going to have a negative 1 charge. There is a way you can write down the result, which is this at the bottom. We have 2 chlorine atoms over here. So we put a big 2 in front of the 2 chlorine atoms. We show that it has a noble gas configuration by putting 8 electrons around it. And each of these chlorine atoms have a negative 1 charge. The magnesium gave away 2 electrons, so it's going to have a positive 2 charge. And this is how you would show a model for magnesium and chlorine. So the next example is to create an ionic model showing the ionic bond formation between aluminum and bromine. So what I want you to do is pause the video and try this on your own by following the steps in order to model ionic bonding. So hopefully you started by writing the electron dot diagrams for aluminum and the electron dot diagram for bromine. Aluminum has 3 valence electrons, bromine has 7 valence electrons. So one of the electrons from aluminum is going to be transferred to our bromine, and bromine is going to have now 8 electrons around it. Aluminum still has 2 electrons left. So the other electron is going to go to another bromine atom, and now it's going to have 8 electrons around it. And because aluminum still has 1 more electron to give away and transfer, it's going to transfer it to another bromine atom, causing each of these bromine atoms to have a -1 charge. And because aluminum gave away all its electrons, it's going to have a +3 charge. And this is what the result is going to look like. We have an aluminum atom that gave away 3 electrons, so it's going to have a +3 charge. And we have 1, 2, 3 bromine atoms that each have 8 electrons around them, and each of them have a -1 charge. And that concludes our video today. Here is a quick recap of things we talked about. Thank you for watching.